So first, I'd like to say thank you for everyone for joining. I'm Chris Bond. I'm the founder of Thinkbox Software. My background is as visual effects supervisor for about 14, 15 years on a variety of feature films and projects. I started Thinkbox Software to build software technology for other studios. And we've been acquired by AWS about a year and a half ago, and we're now AWS Thinkbox. And we have a product called Deadline, which is our on-prem, hybrid, and cloud render management system with a number of features. So a few weeks ago, we did a presentation with Bobo showing off Deadline, rendering a production scene from Fuse FX's project The Tick, where we scaled up on AWS and a bunch of rendering instances. So at the end of that demonstration, by far, we had a lot of questions about building your own software on your instances. So essentially, Deadline ships with a bunch of Amazon machine images, which are AMIs, AMIs. These AMIs have software like Deadline installed, Maya, Max, V-Ray, Redshift, other default renderers that you can choose from. But a lot of our customers like using Deadline on AWS because they can configure and build their own software images and install the software that they use. I know you guys all use a ton of different plugins or renderers, or you want to use the daily build of V-Ray or something like that. And so we give you that flexibility. So by far at the end of the video, number one question by a lot of people was, hey, can you show us how to build and create these Amazon machine images? So that's today's topic. So today, Bobo is going to present on how to use our preset AMIs, as well as how to create new AMIs for Windows and Linux operating systems. So without blathering on further, I'll turn it over. At the end, I'll have some updates and some information and an offer to the folks who watched the webinar today. So please stick around and we'll start now. Thanks a lot.
Hello and welcome to the Custom AMI webinar. An AMI is an Amazon machine image. It defines the operating system and software application to run on an EC2 instance. Deadline 10 comes with several predefined AMIs with typical rendering software, but custom AMIs are required to use any other software not installed on predefined AMIs. In this webinar, we will customize an existing Deadline 10 Windows AMI with 3ds Max to add support for third-party plugins, and we'll customize a Linux AMI with Maya and Redshift to upgrade the Redshift version. First, let's create a 3ds Max test scene. It will contain a particle flow, particle simulation, and we'll use a third-party 3ds Max plugin, in this case Thinkbox Frost, to mesh the particles. Then we'll submit a render job to Deadline. Here is the 3ds Max scene with the particle flow emitting a bunch of particles being affected by gravity and then colliding with some deflectors. We can create a frost mesher, and we'll switch it to Zobritson mode with a blend radius of 2.5 and a particle size of 3. Next, we can assign a standard material to the mesher, and we can set up the render settings. We'll use the scanline renderer, animation of 100 frames, default resolution. We'll create a new output folder, and we can submit with the integrated 3ds Max to Deadline submitter. We'll be using the group 3ds Max, 10 frames per task. We'll be submitting to a custom network path, and we'll have to make sure that the max limit is enabled in order to use UBL. Now we can submit the job to Deadline. In the Deadline monitor, we have the submitted job, and we could start a new spot fleet with the 3ds Max AMI, However, the existing predefined 3ds Max AMI doesn't have Frost installed, so our measure wouldn't render correctly, and the job would technically fail. So instead, we're going to customize an AMI. We'll launch a new instance with the existing one, and we'll create a key pair so we can connect to it. In the AWS console, we'll go to the AMIs, we'll select the list of public images, and we'll search for images containing deadline in the name. They are all owned by the same owner, which is Thinkbox. So we can also filter by owner to ensure that only Thinkbox images are displayed. We can then filter the name by the current version, which the time of this recording is 10.0.17. And here is the base image with 3ds Max and V-Ray and R0. So we can select any compute instance that could run that type of Amazon machine image. And we will create a new key pair, and we'll give the name AWS Portal Demo. We'll have to download that key, and we'll use that key to connect to the instance using remote desktop in order to perform the installation. At this point, we have a pending M4 X large instance, and we'll give it a name, add Frost to 3ds Max, so we can easily recognize it on the list of instances. It is still starting up and initializing. We can take a look at what the content of the private key is. In order to connect to an instance, we can right-click it and select Connect or the Get Windows Password option, but it takes a while before the password becomes available. While we are waiting for the instance to launch, we can download Frost, and then we'll connect using remote desktop, install Frost, stop the instance, and create a new custom AMI. In the Thinkbox software downloads, we'll grab the latest version of Frost, and then we'll return back to the AWS console, and we can attempt to connect again. We can use the connect button in the UI. We can now get the password, choose the PEM file that we generated when we launched the instance. This is our private key, and then we'll decrypt the password and copy it in the Windows clipboard. Now we can download the remote desktop file and launch the remote desktop application with it. We'll paste the password that we decrypted, and we are now logged into the desktop of our EC2 instance in the cloud. Next, we can copy the Frost installer that we downloaded to the desktop using remote desktop. So all we have to do is get to the folder where we downloaded the installer, copy it, and then switch back to the desktop and paste it there. We can maximize again the view, and we see that the file is being copied from our local machine to the remote machine's desktop. Once it is there, we can run the installer. We read the license agreement, we confirm the default path, and we install, and at this point we are adding Frost to 3ds Max 2018. We can now finish, and we can delete this installer. The next step is very important. we open the Start menu and look for EC2 Launch Settings. With this tool, we are going to shut down the machine without sysprep. And then we have to wait for the instance to actually stop, at which point we will be able to create the new custom Amazon machine image. This process can take about a minute or a little bit longer. We can hit refresh and we see that the machine is now stopped. So we can right click it and we can select image, create image, enter the name of the image that we want to create. In this case we call it 3ds Max 2018 with frost. We can also add a description that says pretty much the same, with Thinkbox Frost. And at that point we can create the image. This creates a request. It's a pending machine image creation. This request will be eventually processed by EC2 and the new Amazon machine image will appear, will become available and will appear on our AMIs list. At this point we can create a spot fleet request using this new AMI. We'll then wait for the job to finish and take a look at the result. Inside the deadline monitor we can now once again create a spot fleet request. However, this time we'll use the ability of the dialog to select custom AMIs. So once the dialog appears, we'll check the use AMI ID and we'll click the My AMIs and pick the 3ds Max 2018 with Frost AMI. We can use the default machine selection, make sure that we have a high enough maximum price, and we'll launch 10 instances. We will maintain the 10 instances and we'll have to select the 3ds Max group because the job that we submitted was tagged with the 3ds Max group. We'll leave the rest of the settings at their defaults, and at this point we can launch the spot fleet request. Now we can fast forward through the whole spot fleet request processing. First it will be pending fulfillment, then it will be fulfilled with 10 instances capacity, and eventually the deadline render nodes will appear on the slaves list. And they will pick tasks of our job and render them, and after a few minutes they will all finish. At this point we can take a look at the render output of this job. We can right click any of the tasks and explore the output. In the render output folder that we specified we have all 101 frames of this job, and we can load them in any image sequence viewer to take a look at the result. As hoped, we have our frost mesher meshing the particles that we emitted because we installed the third-party plugin in 3ds Max. No 3ds Max user runs a single third-party plugin in his installation, so let's see what happens if we use PUTTY loaders from KRAKATOA and submit a more complex job that uses 2 plugins. In this scene we have the PUTTY loader loading a cached version of the particles that we saw before with the velocities and positions and IDs, and we also have magma flow that is colorizing the particles based on the magnitude of their velocity, and we have duplicated this PUTTY loader multiple times by rotating it So I have multiple streams of exactly the same simulation being meshed by the same frost mesher. As you can see, we have the combined streams in a single mesher, and we also assign a material with the vertex colors map, so we can render those colors from the magma in the final image. We'll create a new output folder called V010, and we'll submit yet another job with pretty much the same settings as before. But this time we see that all the PUTTs that we cached are listed as assets, and we'll change the name of the job to be also version 10. And at this point we can submit the job to deadline. In order to render this job, we'll have to download KRAKATOA for 3ds Max, start the previously stopped EC2 instance, connect to it using the remote desktop, install KRAKATOA, stop the EC2 instance, and create a new custom AMI, just like we did with the Frost one. From the Thinkbox download page, we can download KRAKATOA, and then we can either restart the already stopped instance that has Frost, or we can launch a completely new instance using the AMI that we have created previously. Of course, launching the AMI as a new instance will take longer, so in this case we're going to just use the instance state start option to restart the currently stopped instance with 3ds Max and Frost. After a while we can connect to it using exactly the same method as before. We'll choose the PEM file from the list and we'll decrypt the password. Then we'll connect with remote desktop using that password. And of course we have to copy the KRAKATOA for 3ds Max installer from our local machine to the remote machine. Now that the installer has been copied, we can run the installer and add KRAKATOA to 3ds Max. We get a message that we need to restart, but technically we'll be restarting the machine anyway because we have to shut it down and then create new instances with it. As you can see, we have in the Thinkbox folder both Frost and KRAKATOA, and we can use the shutdown without sysprep to turn off the machine. Now we can wait for the machine to stop again, and we can create a new machine image with the name Frost and KRAKATOA. And we made the request to create a new machine image. We'll see that is on the list in pending state, and eventually, once it becomes available, we'll be able to render our job, which contains both Frost and KRAKATOA as third-party plugins inside of 3ds Max. In the next step, we'll have to create another Spotfleet request with the newest AMI that contains KRAKATOA, then render and take a look at the result. Once again, we right-click and select Start Spotfleet, wait for the dialog to appear, and then we will be using the option to select the custom AMI, use AMI ID, click the button for My AMIs, and select the one with both Frost and KRAKATOA. I have to set up again the maximum price, the 3ds max group, and the target capacity to 10. And at this point we can launch our spot fleet request and wait for it to be fulfilled. Let's fast forward through the process once again and see that the spot fleet request is being fulfilled. Then the render nodes start appearing. And then eventually they start rendering the tasks of our new job. Once they have finished, we can take a look at the render output of this job, explore the output or view output image, double click any of the rendered images, and load in the default viewer for that image type. As you can see, the measure was rendered for all streams that were cached to PUTTs. What about licensing the third-party plugins that we're installing on the custom AMI? In the case of Frost does not require a license at render time as long as the scene was saved using a commercial licensed version of the product on the submitting workstation. Most KRAKATOA tools can be used in license-free mode, except when rendering particles. For that case, usage-based licenses are available from the Thinkbox marketplace. For any other third-party plugins that require a license, you could forward local floating licenses to the cloud render nodes. In the next section, let's take a look at customizing a Linux AMI to update the version of Redshift to 2.6, up from 2.5. We'll switch to the list of public images. We'll look for deadline and we'll search for the version 10.0.17. In the list of all the provided Amazon machine images, we'll find the one with Maya 2017 and Redshift 2.5. At this point we have to use a GPU enabled instance, G3 for X large will do in this case, and we'll pick the same key pair that we created in the previous session. We can take a look at the instance being launched, and of course we can edit its name so we know what we're doing with it. This is the one for updating Redshift for Maya. We will have to generate a new PPK private key file because the PM file is not supported by the PUTTY that we'll use for SSH connection to the machine. So if we look at the information about connecting to a Linux instance, we'll see that there is a link to the documentation about using PUTTY. You can read through this documentation and follow the exact steps in it. And part of this documentation is also the generation of a new PPK file using the PuttyGen. So we'll use this application to load the existing PEM private key that we saved from AWS. We'll load it. We'll have to switch the list to all files and select the file from our download folder. It will be imported, and then we have to save the private key. We'll switch again the list to all file formats, pick the existing file name, and then switch back to PPK to change the extension, and we'll have a key that has exactly the same name, but an extension PPK. We can use this file to actually connect using PUTTY, and then we'll get the Redshift installer. We'll install it on the instance. We'll fix any missing dependencies, and we'll launch a custom AMI creation out of that instance. We'll copy the public DNS of the machine in order to connect with PUTTY. We'll launch the PUTTY application, paste in the host name or IP address the link that we got from the AWS console, and we'll pick the PPK, corresponding PPK, to the public key that is stored on AWS in order to connect through SSH. The default login for Amazon instances is ec2-user. In my S3, I have created a bucket with a copy of the Redshift installer for version 2.606, and I'll get this version onto the machine. Then I will change its permissions so I can run it, and then I'll run it in administrator mode in order to install the new version on top of the previous one. I have to read through the license agreement and then type in accept. I'll press enter to confirm the default path. At this point, Redshift is installed. We can switch to user Redshift, to the bin folder, take a look at its content. If we try to run the Redshift command line, we'll see that there is a missing library that's been reported. We'll have to check what package provides this library and install the x86-64 version of a package that contains it. We'll take this one, and after we have updated, we can try to run once again the Redshift command line. Redshift command line. At this point we see that the actual command line arguments have been listed, so the executable is happy with all the libraries being in place. Now we can right click and use image create image to launch the creation of a new Amazon machine image, which will have Redshift version 2.6 next to Maya and the deadline slave application. Once it is available, we can create a spotlight request using this AMI. We'll then wait for the job to render, or at least one task of it, and we'll take a look at the reports, or we'll connect to the slave to see that the correct version is being used. We'll use again a custom AMI, the one that we just created. This time we'll use the GPU preset and maximum price of 1. We'll launch only one instance because all we have to test is the log output of the renderer while it's rendering a frame of this job. We are fast forwarding through the actual startup process, and we see that the task is now being rendered, and once it's ready we can take a look at the task reports. In the log we can press Ctrl F and type in Redshift for Maya, and right after that line we see that the Redshift is version 2606, just like the version that we installed. Running the regular Maya with Redshift would actually use a version 2.5. We can see the same from a running slave by just connecting to its log, and we'll see the same information within the log while it's actually rendering, so we don't have to wait for a task to finish to see the version line. In today's webinar we looked at customizing AMIs for both Windows and Linux, both installing new software and customizing existing custom AMIs to add even more software to them, or updating existing software from predefined Amazon machine images to the latest version of the product.
AWS, we have a $500 cloud credit promo and get you started with running on AWS. We call this the Cloud Render Ready program. The idea being that you get set up and tested on deadline 10, do some evaluation with this credit, see how it works, and then when you're ready and when you need it, you're already set up. One of the things that we see frequently is customers, calling in at 3 in the morning or late at night on a Friday saying, "Oh, I need to add 1,000 machines and help me get set up." And so, our recommendation, we have a customer that did this, Fuse Effects, who wanted to test and scale to 1,000 machines just in case. And then that just in case day showed up one time when their render infrastructure failed on-prem for whatever reason. So the next morning they had to scale up massively to AWS, and they were ready. And it was just a couple of clicks. Within a few minutes, they had 1,000 instances rendering. So we strongly encourage you to take advantage of this free credit, and our support team can help you get up and running. So again, if you have any questions about the Omnis or what's coming up next, please post them. I'm going to also mention SIGGRAPH. So during SIGGRAPH, coming up next week, we have a booth, and there's a number of events that we're doing. First of all, we have a AWS booth, and we'll be there at our booth, number 701. We'll have a number of partner pods, including rendering, 3D tools. We'll have a really excellent demonstration of virtualized workstations running at the show. We've been doing a road show demonstrating this with partners Teradici. In this case, we have Teradici and Cumulo for a file infrastructure server. And what we're seeing is a lot of interest in adopting not just the rendering to the cloud, but also moving or transitioning entire projects or studios and virtualizing the entire workflow. There's a lot of advantage to that. So if you're at SIGGRAPH in Vancouver, you should come by our booth and check that out. We also have Amazon Sumerian, AR/VR tool, and Amazon Game Tech, which is VR and a bunch of technologies together that help you build and deploy your games. We're also having a Cloud Tech Talk session on Tuesday. We have a number of really excellent projects that scaled up and rendered on AWS. I'll be opening up the chat about projects that customers did and trends that we're seeing from these. And there's some interesting things that we've seen, and I'll give away one of them now, is that when we first got Deadline up and running on AWS with AWS Portal, we sort of expected our customers to primarily render on-prem, like as in 90% of their work, and sort of only scale up to AWS for the final portion or 10% of their workflow. And what we're seeing instead is customers are actually doing like 90% of the project on AWS. They're taking bigger projects, or they're taking on second, entire films that they normally would decline because they didn't have the infrastructure, and they're doing them almost entirely on AWS. So that means is customers who have something like 300 machines on-prem might scale up to 2,700 on AWS at any given time for a month or two in order to do their project. And that scale is pretty extraordinary. And we were expecting people with 50 machines or 5 machines or 100 machines to add 10% or 20% or double, but seeing 9x or 10x in these companies is pretty amazing. So Mikros is going to be talking about feature film Sherlock Gnomes and what they did on AWS. We have Milk talking about the excellent fluid simulation and water that they did on Drift. And we'll be talking about production in the cloud as well as other items. There's a website there that you can go check out to go see all the events at SIGGRAPH 2018. We'll also be having my favorite event, the Beer Garden, every day at our booth, Tuesday and Wednesday at our booth at the end of the day. So if you're at SIGGRAPH Vancouver, please come by. We do have free exhibition passes. You can go to our website and get that information. So is there, I don't see any questions. So I'm gonna, okay, well, if there's no additional questions, I can either ramble on for a minute or let you guys all get back to your day. I don't think I have anything else to speak about. I'm excited to see and hear from our customers at SIGGRAPH. We'll be making some announcements, and all of those will become public. So watch our website in the next few weeks. And I think that's it.